I am starting. This is the presentation. What is that graph? I want to say you that this is a curve. There is a curve along this line. Is equation as something else that we shall discuss. Now the curve shows that there are some maximum points like this, this, and this, and there are some minimum points, this and this. So if it is so, our job is to find out the maximum minimum of a curve.
Sir,
yes.
Sir, full screen the picture. I can't see it in mobile.
Sure. Mobile. Full screen. Okay. This is actually some reduce. Now it is sufficient, I think. You see, there are some points that this point, this upper point, the upper points, actually they are maximum. At this point, coordinate is something else. It is maximum. And at this point and this point, this is a minimum. So a curve contains a number of maximum points and also the minimum points. Curve contains number of maximum points and number of minimum. Let us see another curve. See, y is equal to fx is the curve. Fx, I will tell you what type of fx it is, and if fx is given, how to find out the maximum points and minimum points. That is our class today. But first to see the diagrams, that this y is equal to fx is this curve, and there are maximum points. Here is the maximum points, here is another maximum points, and here is minimum point. This is neither maximum nor minimum, because I cannot say it minimum because the curve is continuing to go down, but a temporarily settlement is there in the curve, temporary settlement. After that, it will again come down. So this type of point is called saddle point.
So sorry to interrupt
right
you.
Point. So local. These are for all local. Any question? These are all local minimum and local maximum and saddle point. Saddle point, where it is neither maximum nor minimum, but temporary some break of decreasing point. Temporarily some decrease in dy dx, that is comes down. So this is called actually the saddle point. Next curve.
Sir.
Somebody is coming. Yes.
Sir, I think some people are waiting.
Oh, Prashant. That's right. Because they are coming late. What can I do? Okay. So please remember those points in the curve. Follow me. Okay. Coming to the reduce to some point, because reduce some points. Now you see this. Now you can see this. This is a curve y is equal to fx. This is the nature of the curve. This is the max. This is actually the maximum point. This is the maximum point. This is another local maximum point. This is another local maximum. Look, there are 4 local maximum I am considering, but maximum of maximum, that is called global maximum. It is here. Followed it. A curve may have number of maximum points. Because it is wavy, it will definitely get back number of maximum points. But maximum of maximum is called global maximum. And similarly, there are number of minimum points here, here,
Sir,
here.
sir,
স্যার একটা প্রবলেম হচ্ছে যে অনেকে দেখতে পাচ্ছে না মোবাইল দিয়ে যারা আছে, তো আপনি একবার F5 টা প্রেস করবেন একটু?
They are all minimum points. Those are called local minima.
হ্যালো।
Now it is okay with you. It is actually length of the curve is not arranged this way. Now you can see, is it? Some Akhoy Pramani has come. Now we can see. See? Maximum point, maximum point, maximum, maximum, all are maximum point. These are minimum, minimum. Here's the minimum, this is the minimum. But minimum of the minimum is called global minimum. And maximum of the maximum is called global max. That's what I want to say. Huh? That's what I want to say. So a curve will have number of maximum point, number of minimum points. But maximum of the maximum point is called global maximum. And minimum of the minimum point is local like global minimum. Next. This will have to again improve because this is not according to the scale. So there is another curve. Are you looking into the picture? Well, so local maximum is here. Is crossing the y-axis. That is not the problem. This is local minimum. And again increasing. Curve of different nature, we cannot control it because the problem, your problem will be dealt with your own nature of the curve. This is a graph of x cube minus 9x square minus 48x plus 52. So you have to find the maximum, local maximum and global maximum. All these things will come. There is some technology. That technology I will discuss. Before that, I am just placing you the patterns. Next slide. Next slide. In 3 dimensions, it is our knowledge of concern. In 3 dimensions, I allow everybody, but this should not be. It should be within 12 o'clock. Okay. Look at this point, very important. This is z is equal to function of xy. So xy, z are 3 dimensions, x-axis, y-axis, z-axis. Here, there are some maximum point. Here is the maximum point. This is surface actually, you know. Z is equal to function of xy, it is a surface. So here it is a maximum point, here is another maximum point, here is another maximum point. And this is global maximum point.
হ্যালো
Yes.
স্যার এটা একটু ফুল স্ক্রিন করতে হবে, সবার একটু দেখতে প্রবলেম হচ্ছে, তো আপনি একবার স্লাইড শোতে উপরে ক্লিক করবেন।
স্লাইড শো?
হ্যাঁ হ্যাঁ একদম উপর।
এখানে দেখে নিউ স্লাইড আছে, স্লাইড শো।
না না আরেকটু উপরে, হ্যাঁ রাইট সাইডে একটু।
স্যার একটু ডান দিকে উপরে।
হ্যাঁ আরেকটু ডান দিকে।
যারা মোবাইল ইউজ করছে তারা জুম ইন করলেও তো পারে।
হ্যাঁ হ্যাঁ স্লাইড শোতে ক্লিক করুন। হ্যাঁ এবার ফ্রম কারেন্ট স্লাইড দেখুন লেফট সাইডে সেকেন্ড অপশনটা, একদম লেফটে আসুন।
হ্যাঁ ফ্রম কারেন্ট স্লাইড,
হ্যাঁ ওটাতে ক্লিক করুন।
ও আচ্ছা আচ্ছা আচ্ছা,
ব্যাস।
their problem in mobile, they have a problem in mobile I think.
Yes sir, yes sir.
Laptop there is no problem.
Yes sir.
Even mobile. Okay. Maximum minimum in 3 dimension, that is, you know, z is equal to fxy. So if z is equal to xy, then there are, this is the maximum point, this is another maximum point, this is another. These are local maximum points, and this is the global maximum point, right? So this concept is important. That mathematical formulation is there, no problem. But what I am doing, we should be clear about it. Then this is the maximum minimum in 3 dimension. Here you see the local maximum. It is 0 to 30 this coordinate. It is local minimum 2, 0, 20. That's the local minimum. Here it is 3, 1, 17. 3117 global minimum, because no point will come down lesser than 317, and this is local minimum. This is 4220. Next diagram. The equation of the curve is z is equal to fxy is equal to 48x plus 96y minus x square minus 2xy minus 9x square. So if you plot this, it is done in the actually this 3-dimension plotting. This can be done in 3-dimension plotting. What is the nature of the surface? So I am giving you one example, that is minimum point at 21,648, and this way. This is another example. I will go to the up. This is the continuation of this. These are the several minimum points. This is the global minimum, and here it is. One of the minimum is 21,368. Then I'll come back to the other side for mathematical formulation. So I'll escape. What should I do? I shall escape. Okay. Here you are presenting. Stop present. Not. I want to show you some other slides. So what shall I do? Stop present or?
No sir, আপনি just minimize করে যে ফাইলটা খুলবেন সেটা ডাইরেক্ট খুলবেন
সেইটাই
হ্যাঁ
এটাকে ডাউন করে দিলাম এটা আসলে কোড okay. Now the mathematical formulation. So it is done. No, not done. Coming to the beginning of this, it is all in mathematical formulation. The point, I am not inventing any point. It comes from the mathematical formulation. See, there is some technology. 2-3 problems I will dictate you very carefully. Then your job is to follow the problems. Maximum minimum of the function. This is the mathematical part. Maximum minimum function of two variables. A function fx is said to have a maximum or minimum at x is equal to a, y is equal to b, according as f of a plus h, b plus k less than or greater than f a b. Then the maximum will come if you make some shift. A plus h. Shift in x-axis is h, shift in y-axis is h. Then either it will come down or it will be, value will come down or value will increase. So if you make some shift in x and y-axis, if the value remains same, then this is not the maximum point or minimum point, right? Follow this logic. If you make a shift in x and y axis, a shift of h and k in x and y axis. So if you see that h b plus k is less than or greater than f a b, then some maximum or minimum has been occurred. Whether it is maximum or minimum, that is another question. This is some foundation of turning point. That is either maximum or minimum will come out. Then consider the maximum minimum. Taylor's theorem we have discussed in our earlier class, that a b plus h plus b plus k minus the minus f a b. That is f a b was on the right side. Now it is in the left side. Just for mathematical convenience, is h f suffix x, that is partial differentiation of f with respect to x plus k into fy, that is partial differentiation with respect to y at the point ab, plus half h square fxs plus 2hk fxy plus hk square fyy plus higher order terms. So I'll not consider the higher order term. I'll retain up to here. Let k is equal to 0. Let there is no shift in the y-axis. Then for an extreme value, right hand side must be of the same sign for values of h. Right hand side must be same sign for values of h, positive or negative. Since h is very small, the term containing h square and higher powers may be negative. It compares the term h fx ab, but this term changes sign with h. Hence, for an extreme point, fx ab, that is partial derivative of h with respect to x ab, is 0. For this logic, partial derivative of the function with respect to x at the point will be equal to 0, and partial derivative of fy at the point ab is 0. So this will give you some points, coordinate of the points. Those are called stationary points, where the turning will occur. Turning will occur not everywhere. That is whether it is maximum minima, that turning will take place only at the stationary point. To find out the stationary point, we find out fx is equal to 0, fy is equal to 0, and now the sign of will depend on the second term, that is, the second term, h square fxx plus 2hk fxy plus k square fy. So the sign depend on the second term, that is h square fxx plus 2hk fxy plus k square yy. So supposing for our mathematical convenience, that is fxx, that is second order partial derivative with respect to x, is capital A, then the result will be simple. Fxy is equal to b, fyy is equal to c, and say h square, second term, h square fxx plus 2hk fxy plus k square fyy is equal to delta, say, and this is h square a, because I have supposed fxx is equal to a. This is h square a plus twice hk b plus k square c, because I have supposed that capital C is equal to fyy is equal to, I have arranged a little bit, that is dividing by a and multiplying with a, multiplying a in the numerator and multiplying a at the denominator. It becomes h square plus 2hkb plus k square ac upon a. And after writing in the form of square or anything, that is ha plus kb whole square plus k square ab minus b, ac minus b whole square upon a.
Sir, someone is waiting, sir.
Another is waiting. Hi. So you are following up to this? Then I'll come back within a 1 minute. But nobody is waiting, I think. Nobody. No, nobody is waiting. Nobody is waiting. Okay. Already we have come to the conclusion that from this expression, if AC minus B square greater than 0, then the expression HA plus KB whole square plus K square bracket AC minus B square is positive. If this term is positive, AC minus B square is positive, then the whole term delta will be positive. If A is negative, delta is negative, and if xy will have a maximum at x is equal to A, decision will come as this: AC minus B square greater than 0, and if A is negative, then the function will be maximum at x is equal to A and y is equal to B. Second point, if already we know AC minus B square is positive, if A is positive and delta is positive, then fxy will minimum at the point x is equal to A. So this conclusion will come this way. And if we see that AC minus B square is negative, then the sign of delta will depend upon the values of h and k, and hence depend on the values of h and k, and so hence there is neither maximum nor minimum. We cannot say anything. If I see that in a problem AC minus B square is negative, we cannot solve this problem. primary condition is AC minus B square should be greater than 0. Follow this point? Follow this point? And then if AC minus B square is equal to 0, then the case requires further investigation. We cannot say anything. But I should report you once more. That is very, because we are doing maybe the first time. That is why we are accepting the Taylor's theorem of the last class. F plus H B plus K minus F is equal to this term half H square with this. For convenience, let K is equal to 0. Then we see that H is very small. The term H square and higher term is neglected, such as H fxab. But this term changes sign with H. Hence, fxab should be equal to 0 and fyab is equal to 0. These are called stationary point. That is, the maximum minima takes place at these points. So from there, we shall find out the stationary point. Then our job is to second term. Suppose second term is again writing fxx, fxs. I just writing A. A is fxs, B is fxy, C is fyy. Then H square fxx plus 2H fxy plus K square fy is delta. Delta is of convenience. And after some rearrangement, we see that it is HA plus KB whole square plus K square AC minus B square upon A. The term, this delta will be positive or negative, all depends on this term, AC minus B square. See? So, if AC minus B square is the primary condition for decision about maximum minimum. In the problem, there will be no problem. You can understand more well. Then, this is primary condition. If then A is negative, then fxy is maximum at the point x is equal to A and y is equal to A. And if A is positive, we remember this way. A is negative, so maximum. A is positive, then minimum. Just for remembering ourselves, we have built up this remembering. But if AC minus B square is negative, there is no possibility, we cannot say anything about maximum minima. And AC minus B square is 0, there requires further investigation. But this is the working rule. First of all, you find out del f del x is equal to 0. You put del f del x is equal to 0, del f del x is equal to 0, solve the equation. Later, after solving, we get x is equal to A, y is equal to B. The point where fx is equal to fy is equal to 0 is called stationary point. Then find the second derivatives, 3 partial derivatives, fxx ab, fxy ab, and fyy ab. Then you have to check these points. Fxx ab is equal to A, fxy ab is suppose. Then AC greater than B square. That is, AC minus B square greater than 0 means AC greater than B square, and A is negative. Then there is a maximum at x is equal to A. And if AC minus B square and A is positive, there is a minimum at the point x. This is mathematical technique. If AC less than B square, there is neither maximum nor minimum. If AC is equal to B square, the case requires further examination. Somebody is waiting, I think. Now sound has heard. No. Okay. No, nothing. Somebody is chatting, I think. Okay. Okay. Now I can start the problem because I have dictated. If any doubt is in your mind, that will be cleared here. Examine the function x cube plus y cube minus 3axy for maximum minimum. Then suppose there is some maximum minimum. So we're checking out whether there is a maximum minimum. Without, suppose it is a entire plane, then there is a no maximum minimum. Suppose a smooth plane, no maximum minimum. But we have to check as per the last theorem that whether any maximum minimum holds for this point. For a maximum minimum, first partial derivative fx is equal to 0 and fy is equal to 0. From fx is equal to 0, we find out 3x square minus 3y is equal to 0. x square minus ay is equal to 0, y square minus ax is equal to 0. And fy is equal to 0 means 3y square minus 3x is equal to 0. From 1, we see that y is equal to x square by a. From 1, yes. From 1 means here. Y is equal to x square by a. Substituting 2. Anyhow, we have to find x and y. What technology you want to share? No problem about it. We want x and y. So after solving this, substituting 2, we get this, and therefore x is equal to 0 and x is equal to a. From 1, here it is 1. When x is equal to 0, y is equal to 0. And when x is equal to a, y is equal to a. So the points are, stationary points are, I just told you, please remind me, what are the stationary point? That is the maximum minimum takes place where? Because there is a group of points, x is equal to 0, y is equal to 0. One point is 0, 0. See, x is 0, y is 0, so 0, 0. And another is x is equal to a, y is equal to, that is a. At these two places, points, the curve has maximum minimum. But which point is what? Which point is what? That is 0, 0 is maximum point or minimum. That for that we have to come forward. And whether a is maximum or minimum, that also we don't know. We have to examine the following things. So from the curve a is equal to f double x is equal to 6x, b is equal to f, you can partial derivative, take partial derivative and find this one. And so ac minus b square is 36xy minus 9s square. But we have studied that AC minus b square should be greater than 0 for maximum or minimum. Greater than 0. But here we see that at this point 0, 0, AC minus b square is xy 0, 0, so minus 9s square, so a negative. Because minus 9s square is negative, because a is whether positive or negative, it is positive, a square is positive, and so it is negative. So there is no maximum or minimum at the point 0, 0. What can I do? Mathematical foundation will give you permission, then only we should know. So there is no maximum minimum at the point 0, 0. So it is rejected. So we shall examine for AA. There are 2 points. We shall examine for the second point. At AA, AC minus b square is 27a square, and of course it is a positive quantity. So there is either maximum minimum at AA. So the only one point AA contains either maximum minimum. That much is sure. But whether it is maximum minimum, that we don't know. But to examine. Now A is equal to 6x. That is 6a. At the point AA, if A is capital A is equal to 6a. So if A is positive, and there is minimum at the point AA. As per definition, there is minimum at the point AA. If A is negative, also is negative, and there is a maximum at the point A. But it all depends on A. Putting xy is equal to x is equal to y is equal to a, we get maximum or minimum value as minus a cube. So what is the value of the maximum minimum? That is minus a cube. If a is positive, and is the max, a is negative, then there is a maximum at AA. Because if the problem contains a, there is no specific figure. So it depends on a. If a is 2, 3, suppose a is 2, then I can decide right now. If A is 2, then this will be, then A is 2 means positive, and there is a minimum at the point 2, 2. All will be decided if we know the value of it. But it is not given here in this problem. So Specifically, we cannot say it is maximum at that point. Okay. Then come back to the second problem. I think you have understood, you are intelligent enough that one thing I have discussed, it is easy for you. Locate the stationary points of this curve. x4 plus y4 minus 2x square plus 4xy minus 2y and determine their nature. Whether maximum, minimum, anything else. We don't know that. Stationary points are given a first derivative, partial derivative fx should be equal to 0. And if you take the first partial derivative, it will be 4x with respect to x. It is 4x cube minus 4x plus 4y. That is written here. This is equal to 0. This is equal to 0. Adding, because some mathematical convenience. We have to find xy. That's all. Whatever technique you want to use, you can do it. So adding 1 and 2, 4x cube plus 4y cube is equal to 0. And after x cube, after taking plus cancelling 4, it is a cube plus b cube formula. So a cube plus b cube formula gives you x plus y, x square minus xy plus y square. So either x plus y is equal to 0 or x square minus xy plus y. Taking x plus y is equal to 0. So we get y is equal to minus. Substituting into 1. So we get 4x cube minus this. From there we get x cube is equal to 2x. So here it gives x equal to 0 or plus minus root 2. This much you know. There is no problem because x is taken. We cannot cancel x. So either x is equal to 0 or plus minus root 2. It can be done by factorization. And also we get y is equal to 0 minus plus root 2. Alternative. Because y is equal to minus x. Right. So what are the points? Stationary points where maximum minima can occur. Every point cannot be a maximum minimum point. Which point it occurs? That is first option is 0 and 0, x0, y0 is there. Second option, root 2 minus root 2, it is there. Third option, minus root 2, root 2, it is there. So equation 1 and 4 give only the point 0, 0. 1 and 4 is this. 4, this is 1. So it gives 1 and 4 gives only the point 0, 0. So from 1, we get second partial derivative of f is 2x square minus 4. If x was equal to 4, if y was equal to 12, y square minus 4. And from here we get at the points plus minus. If they have written it combinedly, plus minus root 2 minus plus root 2. So fxs is a, fyy is equal to a, but now check it out. AC minus b square is positive, that is AC is greater than b square. That is here AC, if you just a into c, that is 20 into 20 minus b square. B square is 4 square, that is 20 minus 16 is 4, positive. Since a is positive, there are minimum at points root 2 minus root 2 and minus root 2 root 2. There are two minimum points, root 2 minus root 2 and minus 2 root 2. But the one point is left over, that is 0, 0. This is for these 2 points, and from 0, 0 what will happen? If x is equal to a, y negative, and if xy is positive, b 4, and c is minus 4. So AC is equal to b square. That does not give any kind of solution, whether maximum minimum is there. So two stationary points can be obtained from these 2 points. Root 2 minus root 2 minus 2 root 2, and a 0, 0 will not give you anything. But if you put y is equal to 0 in 0, 0, it is this. So when x is very near to 0, if x0 is negative, and so that if x0 is less than this, so that the neighborhood is positive in the neighborhood of 0, 0 in the direction of y 0, that is in the direction of the line y is equal to x. So this is the thing. The 2 points, this one, will give you something. Root 2 minus root 2 and minus 2 root 2. In those points, you will give maximum minimum. The third point, here it is minimum point. Both are minimum point, this one and this one. But the third point, 0, 0 will not give you maximum minimum. Anyway, so another problem. Minimum 3 problems should be there. Otherwise, what I have done, I don't know. Find the stationary points of the function. This z is equal to fxy, that is z. X cube y square 12 minus this way. Any curve will may be given to you for checking out. Satisfying the condition x positive, y positive, and examine their nature. Okay, z is equal to this. So take a partial derivative. If it's c just a partial derivative, so 12 into the 36 x square y square minus 4x cube y square minus 3x square. And after taking common this, fy is similarly f x cube y 24 minus 2x minus 3y, right? So the stationary at the stationary point, fx that is partial derivative is first partial 0, second partial derivative 0, and this yields the points. Since x is not equal to 0, y is not equal to 0, so you get this one and this one. Now my job is to solve it. Anyhow, so fxx is this second derivative. Just take a pen and paper, you will get this. fxy is this, fy is this. At the point 6, 4, a is minus 2304. At the point 6, 4, b is minus 1728 after calculation. So c is minus 2592. Clearly AC minus b square is greater than 0. So it is AC minus b square. Okay, AC minus b square is greater than 0. First point is over. And A is coming as minus 2304. That is negative. Hence, there is minimum at the point 6, 4. Anybody want to anybody want to tell me anything else? Okay. Shall I come to the next point? Let us come, because dot point cannot be there. Similar problem. If your pen is set up, you can do anything. No problem. Your picture will be only, your job is to do the find the maximum minimum. Your job is not to draw the picture. That is those part will be done by who are expert in simulation of the counts. They can do it. So that the function fxy is equal to x cube minus y cube minus 63x plus 12xy is maximum at minus 77 and minimum at 3. Right. As usual, f suffix x partial derivative with respect to x is 0. Second derivative is 0. So from these two equations, after factorization and all this thing, we find x is equal to y or x plus y is equal to minus 1. Putting y is equal to x in 1, we get x is equal to 3 or 7. So the stationary points are 3, 3, minus 7, minus 7. Right. Now check up whether at these 2 points maximum minimum are there. So taking y is equal to 4 minus x, because this is not I have assumed anything. So x plus y is equal to minus 4. So I can just take it, y is equal to 4 minus 6, and substitute in 1. We get this. So this yields x is equal to 5 and y is equal to minus 1. Or this. Or x is equal to minus 1, y is equal to 5. This is the point. So these are the what happened, the other points. Oh, okay. So the points are 3 minus 7 minus 7. And from the third part, x plus y is equal to minus 4. From there we get 2 more points. That is x minus 1, y 5. And x minus 1 and x 5 y minus 1. So for those we have to check up with the usual manner. AC minus b square greater than 0, A is positive. Hence at 3, 3, it is Fx is minimum, and minimum at 3, 3, and maximum at, hence the maximum, what is maximum? And 5, 1, neither, at the point 5 minus 1, at the point minus 7, 7, fxy is maximum. And at the point 5 minus 1, neither maximum nor minimum. Or at the point minus 1, 5, because of this condition, constraints, this AC less than b square and neither maximum nor minimum. So this type of problem is supposed to handle with you. So other problems are there. Other problem is also there. Find the volume of the largest parallelepiped inscribed in ellipsoid. You know ellipsoid? Ellipse you know. Paritra? Ellipse you know. But ellipsoid is something different. That is 3-dimensional figure. Balloon, a big lamba balloon, big balloon. Ellipsoid. So volume is, in this ellipsoid, what is the largest parallelepiped can be inscribed. So volume of the ellipsoid is, volume of the parallelepiped is 8xyz. Why 8xyz? Because length is 2x, breadth is 2y, and height is 2z. So volume is equal to 8xyz. And b square is equal to 16x square y square z square. After substituting, we get this. So f suffix x, as usual, we have to do it. This is 0. F says this is 0. This yields the 2 points. Solving this, x is equal to a by root 3, y is equal to b by root 3. And a is calculated as per this, minus 512 by 9 b square c square, and b is minus 256 by 9 abc square. C is minus 512 by 9 a square c square. Clearly, AC minus b square greater than 0. So there is possibility of maximum minimum. And A is negative since b square is maximum. Value of b square is 64 a square b square c square by 27. Just you put x, y, z, you will get volume, maximum volume, right? So there are maybe other problems, but similar. I can assure you it will be similar problems. So it is some trigonometric problem is there that I'll send you the literature, you can see it. But you first of all remember, you have to make fx, f suffix s is equal to 0, f suffix y is equal to 0. Solve it to find out the stationary points, and for each stationary point you have to check up whether it is maximum, minimum, maybe maximum, maybe minimum, but maybe it is not possible to find out the maximum, minimum. Anything can be there. This is a triangle problem. I will send you the literature. So it's almost the same thing. Approach is same. Yes. What you want to say? Yes. Okay. Somebody is I didn't actually. There are 36, 35 comments. Oh, acha. Next class will going to start, right?
Yes, sir.
Yes, sir.
I found out that from your chats that you are now eager to do the next class. Okay. Somewhat you can achieve, no? Is it in this hour? The technology of finding the maximum minimum. So must be, you have to follow this one, nothing else. You have to follow this technique. Okay, then I am closing this class now.
Thank you, sir.
Okay. Anybody want to ask anything? You can ask me. 1 minute. But if any have any doubts, you can just contact me over phone or anything else. That is my WhatsApp number. Right? Thank you very much. Next class will be on Friday.
Yes.
That is on the Lagrange multiplier method. That is another technique of finding the maximum minimum. This is called Lagrange multiplier method. That will be discussed. Not the difficult, only the mathematical juggling is there. You have to, it is in your syllabus. I cannot escape it. So, Lagrangian method. Next class I'll discuss. So, thank you very much for attending the class.
Thank you.
Thank you.
Thank you, sir.